Okay, so in this particular lesson, we're going to discuss the flaws of voting methods. So I have a preference chart that's given, and we have four choices. And the first, let me describe the problem. So we have voters in a small town that are considering four proposals, A, B, C, and D, and for the design of an affordable housing. The winner design is to determine by the border count method. The preference table for the election is shown. So basically, what we normally say is the highest number of votes in an election would win, right? So the border method violates the criterion, the majority criterion, right? So what we got to keep in mind is, if I were to ask you the following question, let me go ahead and write this out first so you know exactly what I'm asking. Okay, which design has a majority of first place votes? So going back to the border count method, in this case we have four choices, and basically what happens is the border count, it's a family of positional voting rules which gives each candidate, for each ballot, a number of points corresponding to the number of candidates ranked lower. So what we want to do is we want to say, for example, the lowest rank candidate would be 0. Let me write this down, okay? So the lowest ranked candidate will give you 0. Then the second lowest would be 1, right? It'll be assigned 1 point. And then of course the third lowest would be 2, and then the fourth lowest would be 3, and etc., etc., etc. So basically, the border method, okay, once all the votes have been counted, the option or candidate with the most points is the winner, okay? So the border count is intended to elect broadly acceptable options or candidates rather than those preferred by a majority. And so it is often described as a consensus-based voting system rather than the majoritarian one, okay? So going back to the question, which design has a majority of the first place votes, all right? In order to find that, we must find the total number of first choice votes and then determine which design received more than half of these votes. Remember that 1/2 definition? So we go to the first choice row and we need to count the total votes, okay, number of votes. And if you look on top, you got 500, 200, 150, and 100. When you add all those up, okay, you'll get 950 votes. Okay, so you add them all up. Okay, and you get 950 votes. So you have to do that first. So since there are 950 first choice votes, okay, we need to determine which design received more than half of these votes. Okay, which in this case, half would be 475 out of 950. Okay, so we need to determine, when you add them all up, determine what's half of 950, and it's going to be 475. All right, so once we establish that, then you look at the giving preference table, and you can see from the top row that B did not receive the majority of the first votes. Okay? So what we're doing is okay, so what we're going to examine now is we're going to go back to that first row, D, C, C, A. You notice that there's no B in there. Okay? That means that design B did not receive any first choice votes. Okay? So basically, C received 200, okay, and then the other C category received 150, and then of course, we add those up and you get 350 first choice votes for C. Okay, so let me write that down. Okay, so for C, okay, based on the first row, right? The first C received 200, and then the other C received 150. So that gave me 350 first choice votes. Okay. So going back to that first row, D, C, C, A, I added the two C's, 200 and 150, and I got 350. And then the design that received 475 or more first choice votes is design D. Okay, design D is 500. That's right over here. Okay, it's 500. All right, so design D received 500 first choice votes. And 500 over 950, okay, is going to be greater than 1/2, okay? So that's why D is the winner. Okay, and then for the second part, I want you to use the following table, which I'm going to put on the next slide. Okay, so we're going to use the following table. I know it looks a little bit overwhelming. We got 4 choices, and basically what we're doing is we're referring back to this table that was given here, okay? And so just so you know, this total number of votes for each column remains the same, 500, 200, 150, and 100. Okay, so we want to determine we want to use the border count method to find the winner of the election. Using the border count method with 4 designs, a first place vote is worth 4 points, a second place vote is worth 3 points, a third place vote is 2 points, and a fourth place vote is 1 point. So we need to keep that in mind, okay? So I'm going to write that down. We need to, this is given now, okay? This is given in the problem that I just mentioned. So first place, is 4 points, okay? And second is 3. Third is 2. Okay, and fourth place is 1 point. Okay? So that's the system we're going to use. Okay, so now the table below shows the points produced by the votes in the preference table. Okay? In the table above is basically all the letters that I underlined is from that preference table that was given originally. And since the first choice row, you notice that D had 500 votes. So basically the first choice, first place, is awarded 4 points. So we do 4 times 500, and that's what this is. Okay, and then if you look at the first choice for C, there's 200 votes, so we do 4 points times 200. Okay, and that gives you 800. And then of course it repeats again here. This C column is 150, assigned 4 points to that, and gives you 600. And then of course the first choice for A, okay, is 4 times 100. Okay, and we just do the same thing for the rest of the variables, and the rest of the letters. Okay, so you need to use this scale, this point system. All right, so now the total number of points for each design, okay, 1 second here. So in order to determine the answer to this question, the question is determine, the design with the most points is the winner. So what we got to do is we look at all the, look at this table, and you add up the letter that has the most amount of points. Okay, so if you were to do that, okay, you're going to see that design A is going to be the winner for time's sakes. Okay, so here's A, it's 450, and then the other one is here. Okay, and if you do the other ones for the other letter, you will get a lower amount. So A is going to be the winner. Okay, so we add all those numbers. The first A was what, 1500? All right, and I got that. I got that right here, 1500. Okay, then we're going to add the other A, which is 600. Really doesn't matter the order. And then we're going to add the other A, which is 450. And then last but not least, the 400 here. And when you add all those up, you get 2,950 votes. Or points, I should say. Therefore, using the border count method, the design that will be used for the affordable housing is design A. Okay? And then the other question, the majority criterion, states that if a candidate receives a majority of the first place votes in an election, then the candidate should win the election. The design that received the majority of the first place votes would be D. Okay? So if you go back to the D column, the chart here, and add all the D's up, okay, that would win the first place votes. Okay, and it's going to be what, D is 2,000 up here. Okay, so yeah, you just add all the first place votes. So the first place votes is the first row. D is going to be the winner, 2,000 points. Okay, the design that won the election is design A. Okay. So if D received the majority of first place votes, okay, then that design should win, right? But it's not. If you add all the A's up, you get 2,950. Okay, so it's going to be more than D. All right, the number of first choice votes for D in that first row is 2,000. Okay, it's going to be 2,000. Well, 2,000 is a lot less than 2950, right? Okay, so the design that received the majority of the first votes is D. The design that won the election is A. Therefore, the majority criterion is not satisfied because the design with the majority of the first votes lost the election. Okay? So that is how that border method works. I know that it was a lot of information. I hope, if you review the video again and see what I've done, you will be able to follow along, even if it takes a couple of times, all right? But at least you have a systematic process to go through the problem to get your answer. So that concludes that problem. Okay, so in this particular problem, we're going to use the head-to-head comparison, which is pretty easy once I explain it. The problem that we're going to talk about is there's a reality show considering 3 cities. Okay, city A is going to be Austin, R is going to be Rome, and B is going to be Denver. A chosen group of people will vote to decide where a new season will be taped. The winning city is to be determined by the Plurality Method. The preference table for the election is shown, which is given right here. Question A, which city is favored over all other cities using the head-to-head comparison? Now, when you do this, you got to choose a comparison with 2 variables. In this case, 2 letters. Do you want to compare A and D, R and D, etc.? So we will decide to do, we're going to compare city A and R. It really doesn't matter. We're just going to choose A and R. All right. So the question, again, is excuse me. Sometimes this pen slips a lot. It's hard to write. Okay. So the first question that I'm going to ask is which city is favored over all others, okay, using the head-to-head comparison. All right, head-to-head comparison. So again, we're going to choose A and R. We're going to compare A and R, or A to R. And when we look at these tables, each column, we want to pick which city, okay, A is over R, okay? So we're comparing all the A's and R's for each column. So if you look at column 1, okay, A is over R. A is favored over R because A is first, R is second. Okay? In the second column, okay, R is favored over A. So that column lost. The third column, A is favored over R. And the fourth column loses because R is favored over A. So since we're comparing A to R, we add the total number of votes for those columns, which is 120 plus 140. And when we do that, we get 160 votes. So therefore, city A is favored over city R in the first and third columns. Therefore, city A receives the most votes. Now, city R is favored over the A in the second and third columns. Okay, so And when you do that, so in the first and third columns, if you add 81 plus 40, that's only 121 votes. So again, they lose. That's how you prove that they can lose. Okay, but in simple terms, it's A over R in whatever column that appears. Now let's compare city A to D. Okay, A to D. So look at each column and determine what column, each column determines what columns determine A is favored over D. Well, the first column is clearly 120. The second column, D is favored over A, so that's not going to count. Same thing with the third column, but the fourth column, A is favored over D. So when you add 120 plus 40, you get 160 votes. Now, 160, is that correct? Yeah, okay. So, we're comparing A to D, right? Yeah, okay. So, okay. And of course, in the second and third columns, D is favored over A. Okay. So, when you add 81 plus 40, you get 121 votes. So, 81 plus 40 is only 121 votes, so that loses. All right, when we compare A to R, A is favored over R in the first and third columns, but D is favored over R in the second and the third columns. So when you add 81 plus 40, you get 121 votes. That's less than 160. So those comparisons, right, lose. So definitely city D is favored over A in the second and third columns. So city D receives the 121 votes. So in conclusion, city A receives more votes than city D. City A is favored over city D. All right. Since city A is favored over both city R and D, we say that city A is favored over all of the cities using the head-to-head comparison. So let's recap what I said. A is favored over R. City A is also favored over city D based on these two conclusions. Okay? So based on the head-to-head comparison, okay, we can say that A is favored over all other cities Okay, so since city A is over R and D based on those two orange check marks, we can say that city A is favored all over the other cities using the head-to-head comparison. Okay, now using the plurality method, I want to know which city wins the vote using the plurality method. So when we do that, okay, the total first choice votes in each city, city A in the first choice column is going to be 120 votes. City R receives 40 first choice votes. City D receives 81 and 40, which gives you 121 votes. So the city receives the most first choice votes, is the winner of the election by the plurality method. Therefore, city D wins. Okay, so when you add 180 and 40, okay, you're gonna get 121, and 121 is bigger than 120 and 40. So D wins. Okay, city D wins. And for the third question, is the head-to-head criterion satisfied? Why or why not? Well, as I said earlier, the head-to-head criterion states that if a candidate is favored when compared head-to-head with every other candidate, then that candidate should win the election. City A is favored over cities using the head-to-head comparison, but D wins because it received 121 votes, or first choice wins. Okay, so that's how it works for the head-to-head comparison. Okay, so in recap, you just choose any two that you want to compare, and you look at each column, and you choose the one that compares over the other. Okay, add the votes for those columns, and you'll see the number of votes that you'll get, all right, for each comparison. Okay, so I hope that was helpful in that particular problem. I know that's a mouthful, but that's generally how the head-to-head comparison works. All right, so I hope you found this video very helpful, and I will see you later. Thank you.